So I'm going to be teaching you the product and quotient rules to start off with. I'm also going to be teaching you something called the chain rule afterwards. So first of all, we've already seen the power rule, and so we're going to take a look at the proof of what are called the product and quotient rules. So when I am taking a look at the product and quotient rules for derivatives, remember that product means that we are going to be multiplying them. So I'm going to be proving this product rule and showing you sort of how the product rule kind of works. But before I do that, I want to just show you something, okay? So the first note that I'm saying is that if you have h of x is equal to like f of x times g of x, you can't just take the derivative of this thing by taking the derivative of the first function and multiplying it to the derivative of the second function. Unfortunately, derivatives don't work exactly how we want them to be. For example, if I had h of x to be something like x squared times x cubed, I can't say that h prime of x would equal to 2x, which is the derivative of x squared, bring the power down, reduce the power by 1, times derivative of x cubed, which is 3x squared, bring the power down, reduce the power by 1, and what I would get there is 6x cubed. So that is not the truth, because if you actually think about how h of x would work, x squared times x cubed would be x to the 5th. And if we did our little song, bring the power down, reduce the power by 1, we would actually get a derivative of 5x to the 4th, which as you can see is not equal to 6x cubed at all. So in that way, we can't actually just take the derivative by taking the derivative of each one of these things. So what we have to do is we have to figure out what to do if h of x is equal to f of x times g of x. Now I'm doing this via video because I want you guys to actually have access to how to prove the product rule, just in case at some time in your post-secondary future you might be asked to do something like this. There is a secret to it. A secret that when I was in your shoes, I did not know, and so it was very difficult for me. So I want to tell you what the secret is. And I'm going to be doing this by the definition of derivative. So for me to find h prime of x, it's going to be by the definition of derivative, the limit as little h goes to 0 of big of h x plus h minus big H of x, all divided by little h. So think about the little work on the side that you do. If h of x is equal to f of x times g of x, then h of x plus h, little h, is equal to f of x plus little h times g of x plus little h. And so what I get is this. I get the limit as h goes to 0 of, I'll put this in here, f of x plus h times g of x plus h minus h of x, right, this guy right here, which is f of x times g of x, and it is all divided by little h. So even though there's a lot of f of x plus h's and g of x plus h's and all that kind of stuff, I would hope that we could all do this. But this is where the secret comes in. And if you don't know the secret, the next step is kind of difficult. So what I'm going to do is I'm going to show you the secret to this and then show you how we would proceed with this proof. So the secret is that you have to add and subtract something in the middle of this function. So right along the top of this thing, I'm going to subtract and then add. I'm going to subtract f of x times g of x plus h, and I'm going to add f of x times g of x plus h. Now you might think to yourself, well, why the heck am I doing that? Well, you'll see. It'll happen for you here. But the idea is that by adding and subtracting that stuff in green, you're not really changing the question. What you're doing is you're adding and subtracting these terms so that you can actually start grouping these things together and grouping these things together. And just like we did with trig limits, we are going to split up these limits as we go through. So I'm going to split up the first half, and I'm going to get the limit as h goes to 0, little h goes to 0, of the first two guys, And I've got f of x plus h times g of x plus h minus f of x times g of x plus h, and it's over h. And then plus, because I'm going to split up my limits, I've also got the limit as h goes to 0 of all the other stuff. I've got f of x times g of x plus h minus f of x times g of x, and it's all divided by h as well. So that's common denominator of h. Now I'm going to do a little bit of factoring. I'm going to take out the greatest common factor from the top of this fraction right here. And the greatest common factor is g of x plus h. So if I factor out g of x plus h, so I'm factoring away the g of x plus h here and the g of x plus h here, I am left with times, bracket, f of x plus h minus f of x. And then the whole thing is over h. And I'm going to do the exact same thing to that second fraction. As you can see, this is a fairly long and sort of involved algebraic proof, but like I said, I'm doing this so just in case you ever have to see it in your future, you know what the secret is. My GCF for this one right here is f of x, so I'm going to factor out my f of x, and I'll be left with, once I factor those guys out, g of x plus h minus g of x, and it's all divided by h. Now, I'm going to split these up algebraically even more. So just again, like we did with our trig limits, I'm going to see what I'm going to get. So I'm going to split this up into g of x plus h over 1 times the limit as h goes to 0 of all the rest of it, which is f of x plus h, and then minus f of x over h. So that's what I've got for this first thing. I've got the g of x over 1, and then the limit as h approaches 0 of f of x plus h minus f of x over h. And again, we're getting that exact same thing as we started off with right here. I'm going to do the same thing for the next one. I'm going to split the thing out, and I'm going to get the limit as h goes to 0 of f of x over 1 times the limit as h goes to 0 of g of x plus h minus g of x over h. And now we're going to find the limit of these things. So it's pretty easy to find the limit of this guy. So if we think about what that limit is, I'm going to let h goes to 0, and I'm going to get g of x plus 0, which is just g of x. And then I've got a times value here. This one is the secret, because this one, hopefully, you recognize. Hopefully you've said this over and over to yourself for the last couple of days, and you find out that the limit as h approaches 0 of f of x plus h minus f of x all over h is, in fact, f prime of x by the definition of derivative. So that whole thing, as we went through that definition of derivative, is what we're getting for f prime of x. And then I'm going to get a plus sign. There's my plus sign. I now let h go to 0 here as well. And if h goes to 0 and there's nothing to plug it into, I'm getting that f of x business right there, times, there's my times sign. Now take a look at this guy over here. Ooh, I'll do it in rainbow. So we've got ourselves a little rainbow over here. We've got this guy. This is very similar to what I see here in green. In green, we've got the limit as h approaches 0 of f of x plus h minus f of x over h, and that was f prime of x. In rainbow, I've got the limit as h approaches 0 of g of x plus h minus g of x over h, and that's going to give me g prime of x. So that, in a nutshell, is what the product rule tells us to do. It says if you've got the product, or h of x is the product of two functions, so f of x times g of x, then what we've shown is that h prime, when you take the derivative, is, and I'm actually going to write it a little bit differently. I'm going to write it as f prime of x g of x, and then plus g prime of x f of x, and I'll tell you why in a second. It's how I remember it. Some textbooks will show something like this instead. Y is equal to u times v, so two functions, u and v. Then when we're finding the derivative of them, you take the derivative of u first, and then v sort of sits there. And then you take the derivative of v first while u sort of sits there. Personally, I call this the buddy rule. because of course you know me, I need ways to remember these things. And so I think of the U and the V as being two buddies. So here's U and there's V. They're really, really good friends, and they're going to get an opportunity at being the derivative. So when you're being the derivative, our buddies are so nice. They say, oh, you go first. No, 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 you go first. And so U is going to go first. So U's first at being the derivative while V waits for him. And then V gets a chance at being the derivative while you wait for V. So everybody gets a turn at being the derivative. And in fact, even if there were three friends, let's take a look at what would happen if there were three friends. And we have U times, let's see, V times W. If we had three friends and they're all really good friends and everybody wants to have a turn at being the derivative, what's going to happen is they let everybody have a turn. So U is the derivative. I should say, let's do this again. U is the derivative while V and W wait for him. So V and W wait for U to be the derivative. And then who comes next? Well, maybe V comes next. V is going to be the derivative while U and W wait for him. And then who needs to be the derivative still? Oh, W needs to be the derivative still while U and V wait. And so when we're dealing with the product rule, we are always dealing with the fact that everybody's going to get a turn at being the derivative. So let me show you an example of how the product rule works. The product rule is really sort of useful for when we deal with function notation and we start dealing with special derivatives a little bit later on. But let's start with this one. I'm going to see f of 5 is equal to 2. And f prime of 5, I'm giving you these things, is equal to negative 4. Find h prime of 5 if h of x is equal to x cubed times f of x. So as soon as you see this little product thing right in here, now you're thinking, hey, there's two buddies. The first buddy's name is x cubed, and the second buddy's name is f of x. So when I try to find the derivative of this thing, and I try to find the derivative of h prime of x, my first buddy is going to be the derivative. So the derivative of x cubed, bring the power down, reduce the power by 1, we get 3x squared. And the second buddy just sits there and waits with a plus sign in between. Now we have to be fair. F of x is going to be the derivative, so f of x gets a turn at being the derivative, while that first buddy just sits there and waits. Now, if I wanted to find h prime of 5, there's my function notation popping in. Wherever I see an x, I'm going to put in a 5, and I'm going to get 3 times 5 squared times f of 5 plus f prime of 5 times 5 cubed. And so I'm going to get 3 times 25, which is 75, times f of 5, which is given to us, which is 2. And then f prime of 5, which is negative 4, times 5 cubed, which is 125. 75 times 2 is 150. Negative 4 times 125 is 500, negative 500. And so my answer would be negative 350 is equal to h prime of 5. Keep in mind about what this means. That means that the slope of the tangent line to h of x, which was x cubed times f of x, when x is equal to 5, is negative 350 over 1. So I have a rise of negative 350 and I have a run of positive 1. Okay, so let's move on now to the quotient rule. Sorry, my cat is sitting all over everything right now, so I have to just move her around. Here you go. Okay, there we go. Very helpful. The second thing that I'm going to be taking a look at today is I'm going to be taking a look at the quotient rule. So a quotient is a fraction. And we're going to be taking a look at the quotient rule, which says that if h of x is equal to f of x divided by g of x, we want to figure out what h prime of x is going to be. Okay, and with the quotient rule, same as before, if you have h of x is equal to f of x over g of x like this, h prime of x is not going to equal f prime of x divided by g prime of x, unfortunately. So we have to figure out a way of doing this. Now, the proof for the quotient rule, the algebraic proof for the quotient rule, is like identical to the product rule. You still add and subtract that middle number, and then you do the factoring and all that kind of stuff. So I'm just going to go through this a little bit more quickly, and I'm not going to actually use the product rule for this. How are we going to use the product rule? Well, I'm going to write this as h of x is equal to f of x over g of x. And I'm going to rewrite that by getting a common denominator that h of x times g of x over g of x is the same as f of x over g of x. And there is my product. And we're just going to use that product rule to find the derivative of this thing. So, okay, when we're doing the product rule, my first buddy is going to be the derivative while my second buddy waits. And then my first buddy is going to hang out and wait while a second buddy is being the derivative. So because it's multiplication, it doesn't really matter which one goes first, right? My first buddy is waiting, second buddy is being the derivative. And on the other side, the derivative of f of x is just going to be f prime of x. So what am I trying to solve for? Remember that the whole purpose of this is to find h prime of x, so I want to get the h prime of x all by itself. I'm going to subtract this from both sides. So I'm going to get h prime of x times g of x is equal to f prime of x minus h of x times g prime of x. I'm getting rid of this. I'm subtracting it from both sides. Then to get h prime of x all by itself, I'm going to divide by g of x. So I'm going to get f prime of x minus h of x, g prime of x, all divided by g of x. There's one more problem with this, though, is that we have to remember that h of x in the first place was f over g. And we need to really get rid of that h of x in my original. So we've got f prime of x is minus f of x over g of x times g prime of x, all divided by g of x, which unfortunately has brought us to a complex fraction. Yuck. So I'm going to multiply the top and the bottom by g of x. When we multiply the top and the bottom by g of x, I'm going to multiply that into there, and I'm going to show you how I'm going to write this. So I'm going to write g of x first, and I'm going to write f prime of x second. It really doesn't make any difference, but this is how I've remembered it, and this is what I'm going to be saying every time to you, so I might as well do it the same way. When I multiply this into here, the g of x is going to cancel off, and I'm going to be left with f of x times g prime of x. So I'm going to write f of x times g prime of x. And in the denominator, what I'm going to be doing is I'm going to be multiplying this into here, and I'm going to get g of x all squared, or g squared of x, if you wanted to write it like that. Now, there's no buddy rule for this one that I can help you with, but it tells me that if you have h of x is equal to f of x over g of x, the way that we're going to find the derivative of this thing, and you're going to hear me say this a lot, is that you take the bottom function first. So this entire bottom function right here starts the top. Bottom function times the derivative of the top minus the top function times the derivative of the bottom, all divided by the bottom function squared. Or if you prefer to have y is equal to u over v, your y prime value is the bottom function, that's v, times the derivative of the top, minus the top function, that's u, times the derivative of the bottom, all divided by the bottom function squared. So let me give you an example. We are going to find y prime if y is equal to, let's do two of them. So if y is equal to 1 over 2x. For this one, you actually have a choice. You could use the power rule. And the power rule, you'd have to rewrite y as 1/2 x to the negative 1. And then you can bring the power down, reduce the power by 1, and you would end up with negative 1/2 x to the negative 2, or negative 1 over 2x squared. That's going to be what your derivative is going to be. Or you can use the quotient rule. If I use the quotient rule, this is how it works. Y is equal to 1 over 2x. That's my u over my v. Okay, so y prime will be the bottom function, which is 2x, times the derivative of the top, and the derivative of 1 is 0 since it's a constant, minus the top function, which is 1, times the derivative of the bottom, the derivative of 2x to the power of 1, bring the power down, reduce the power by 1 is going to be 2, all divided by the bottom function squared. So let's simplify that. Out the top, 2x times 0 is going to be 0, minus 2, I'm going to get negative 2. 2x all squared is going to be 4x squared, and when I simplify that, I'm going to get y is equal to negative 1 over 2x squared. Same answer. So with this one, you get a choice, but with our next one, you do not get a choice. So if I had something like 2x squared plus 1 over x squared minus 3, there is no choice for this one. You must use the quotient rule, because you can't write this as just 1 power of x. So when we take a look at this, we think about your y is equal to u times your v. This guy is your u and this guy is your v. So your y prime value is your bottom function, x squared minus 3, times the derivative of the top. The derivative of 2x squared is 4x. The derivative of plus 1 is 0. Minus your top function, 2x squared plus 1, times the derivative of the bottom. The derivative of x squared is 2x. The derivative of minus 3 is 0. All divided by the bottom function, x squared minus 3 squared. So when you deal with something that looks like this, you must expand the top, if possible, right? If you can get your collect like terms and all that kind of stuff, you have to do it. But don't expand the bottom. The reason why we don't expand the bottom is because the bottom is already factored. I don't need to be able to do anything to it. I do need to expand out the top so that I can collect my like terms and simplify as much as I possibly can. So I'm going to expand out the top here, and I'm going to get 4x cubed minus 12x. And I'm going to expand out the top here. I'm going to get a negative 2x times 2x squared, so negative 4x cubed. And a negative 2x times 1, which is a negative 2x, all divided by x squared minus 3 squared. So finally, if I simplify this, my 4x cubed seem to cancel off, and I'm going to end up with negative 14x on the top and x squared minus 3 squared on the bottom. That gives you a little idea. You don't need to perfect this today. You just need to see how it kind of works, because tomorrow we're going to be working all over this thing. All right. So now the third rule that I'm going to be taking a look at is going to be something called the chain rule. And from now on, you are no longer going to be doing sort of any derivatives unless you have the chain rule with you. So the chain rule is kind of a weird one to prove, and that's, maybe you can just sort of take your time and one step at a time as I go through this. But the chain rule is for us to find the derivative of what is called a composite function. And what I mean by that is that your h of x that I'm looking for in this one is going to be f of g of x. One function is tucked inside another. And what we need to be able to do is we need to be able to find h prime of x. So when we use the definition of derivative for this one, and I am going to show you this one because I've seen this one being used on like midterms and stuff at university a bunch of times. It's a weird one. So when we are finding h prime of x, what we're looking for is we are looking for the limit as h approaches 0 of f of g of x plus h minus f of g of x all over h. So this guy is being replaced by x plus h in the first one, and then it's just regular f of g of x for the second one. Now, for us to be able to figure this out, there's a lot of f of g of x's, and it gets fairly complicated. So I'm going to use some dummy variables, okay? I'm going to do this. I'm going to let v equal to g of x plus h. I'm going to let w equals to g of x. Okay, so if I think, and oh, I'm also going to go v minus w is equal to k. So if that is the case, then what we get here is we get g of x plus h minus g of x is equal to k. Or if you want, g of x plus h is equal to k plus g of x, or k plus w. I'm just playing around with some dummy variables for right now, and we're going to refer back to this as I go through the question. In addition to this, one more thing. As little h goes to 0, think of little h going to 0 right here. Okay, so we want to think about this thing. As little h goes to 0 right here, it means that k is going to have to go to 0 as well, because you get g of x minus g of x. None of this is going to make sense to you right now, but we're going to refer back to this stuff as I go through the proof. So here's what I get. H prime of x is equal to the limit as h goes to 0. Can you hear the cat purring? The limit as h goes to 0 of f of x plus h, or sorry, f of g of x plus h. I'm just going to write this out one more time because it'll lose it off my screen. Minus f of g of x, all divided by h. And now I'm going to start substituting. So notice that we said that v was equal to g of x plus h. So right there, what I'm going to get is I'm going to get the limit as h goes to 0 of f of v. Minus, we also said that w is going to equal g of x. So what I'm getting in here is f of w and all divided by h. Going back up to this little box, you remember that g of x plus h right here was equal to v. So v is also equal to k plus w, or w plus k. So I am going to do one more substitution, and then we're going to start splitting this thing up. It's a little bit on the weird side, okay? Are you ready? So because v is equal to k plus w, or w plus k, I'm going to write that v is equal to w plus k. What I'm getting here is f of w plus k minus f of w, all divided by h, and I'm going to start editing this. So now I've got f of w plus k minus f of w all over h, and I'm going to multiply by k over k. Doesn't change anything, but what it's going to do is it's going to allow me to split this thing up. And I'm now going to write this as the limit as h goes to 0. Actually, I'm going to write this the limit as k goes to 0, because if h goes to 0, k goes to 0, of f of w plus k minus f of w over k times, what do I have here? K over h. So you might think, oh, that's kind of weird. Why would I do that? Because now what I'm going to do is I'm going to split up this limit. The limit as k goes to 0 of f of w plus k minus f of w, all divided by k, and I'm going to times it by the limit, and I'm going to go back to the original again and go h goes to 0 of k over h. Believe it or not, even though this doesn't look like it makes much sense right now, We are almost finished, and we've got this little idea here. So here we go. We've got the limit as k goes to 0. Start recognizing. Think definition of derivative. That's a W, by the way. And over here, I'm going to substitute in whatever I can. And in the denominator, it's going to be h. And on the top, it's going to be k. So let me scroll back for a second. K, right up here, what was k equal to? Well, if I rearrange this thing here, k is equal to g, oh, I don't even have to, it's right here. K is equal to g of x plus h minus g of x. So what I'm getting here is g of x plus h minus g of x. All right, now, it's been a long haul. You've got a lot of proofs under your belt at this point right here. This is the key, right? We know this as my definition of derivative. F prime of x is equal to the limit as h goes to 0 of f of x plus h minus f of x all divided by h. That's what that means, right? We're finding that derivative of that function. Well, take a look at what we have here. We've got limit as k goes to 0, so k is like in the denominator here, of f of w plus k minus f of w. So this first one right here is going to be f prime of w. Instead of using x, we're using w. Instead of using h, we're using k. All the stuff is the same. And then we are multiplying by this guy. And this guy over here is just g prime of x. Going right back to the beginning and taking a look what w equaled, I'm going to go back up in here. What did w equal? Oh, it was g of x. Going right back up there, what we have is we have this thing. We have f prime of g of x times g prime of x. All right, so here it is in a nutshell. You've got h of x is equal to f of g of x. And in order to find the derivative of this thing, h prime of x, you're taking the derivative of the outside shell. You see that function f is the outside shell, but you're keeping the inside exactly the same. And then you're multiplying it by, that's called chaining it up to. You're chaining it up to the derivative of g of x, which is my inside function. So you take that inside function and you chain it up to the derivative of the inside function. So that's where we're getting this chain idea from, is that you're always chaining this up to the derivative of the inside. I will show you one example, then you're done for this, because all we are doing in the next class is figuring out how you can put all the mechanics of this stuff together, okay? You don't have to practice this tonight. So what we're going to do is I just want to show you how one example works. Let's say I had h of x, I might as well use h of x again. Why don't I use h of x to be 2x squared minus x plus 1 to the power of 10. Nobody wants to multiply this out, okay? You could, if you really wanted to, multiply this out to the power of 10. But what's really happening is that you have h of x is equal to something to the power of 10. There's my inside function. And so what I'm going to do is I'm going to take the derivative of this thing. So when we are dealing with the chain rule, you always have an outside function, which is doing something to the stuff, and then the inside function, which is essentially the stuff. So my outside function is something to the power of 10, and my inside function is all that stuff in the middle. You guys are capable of taking the derivative of u to the 10th. We bring the power down, we reduce the power by 1, and now things are different because now we chain it always to the derivative of the inside. And the derivative of the inside is going to be u prime. So on the back here, I'm going to have u prime. So let's see what it looks like. H prime of x is equal to 10 times something to the 9th times the something. The inside here, if you're taking a look, this guy right here, that's my u. This is something to the power of 10. So it's bring the power down, reduce the power by 1, Don't change the inside at all. Then we chain it up to, that's the multiplication, the derivative of the inside here, and the derivative of the 2x squared is 4x. The derivative of minus x is minus 1. The derivative of plus 1 is 0. This is your final answer. A lot of the times you'll find that in most textbooks they go from smallest to biggest factors, so they would write the 10 first, and then the 4x minus 1 next, and then the 2x squared minus x plus 1 to the 9th last, and you'd get that as your answer. Again, don't freak out about this, right? We're just getting the idea of this rule right now, and what we're going to do in class tomorrow is we're going to spend the whole day figuring out how to do your product rule, your quotient rule, and your chain rule until you're super, super good at it. All right, thanks, and I'll see you tomorrow.